All right, today we're going to be starting a new concept of sequence and series. Now, this is the start of chapter 12. Today we're going to start with the basics, and then we're going to dig deeper into those concepts later, but today's going to be the basics. So hopefully, sequence and series, you can kind of tie connections into what you know from the past. But it is exactly what it sounds like. We're going to be looking for sequences, which is sets of numbers, and series, which is more, in a sense, kind of like patterns. Now, the first thing we're going to look at today is sequence. A sequence is an ordered collection of things or an ordered list. Okay, and we're specifically obviously going to be looking at numbers. So we're going to look at an ordered collection of numbers. Now, the key word here is ordered. We're going to have to figure out those orders. What is it? My first example, sequence number 1 is 4, 8, 12, 16. And now hopefully before we even get into it, you guys can tell me that has an order, that has a pattern. It goes up by 4 each time. 4 plus 4 is 8, plus 4 is 12, plus 4 is 16. Sequence number 2, 5, 10, 15, 20. Also has a sequence, also has a pattern, goes up by 5 each time. Now, a function, we've talked about functions before. We've also talked about domain and range. We're going to kind of rephrase what we've talked about in the sense of domain and range before. Now, domain, as we hopefully can remember from the past, is your x's. And remember, your x-axis goes left and right. Range is your y's, and your y's go up and down. Now, this is the domain is the set of consecutive integers. Okay, set of consecutive integers. Think about that if we're talking about an XY chart. Domain is as we go to the right. 1, 2, 3, 4, 5, 6, 7, 8, da 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 da. So your domain is in a sense where you're at. You're at the first term, the second term, the third term, the fourth term, the fifth term, the sixth term, the seventh term, the eighth term. So you're just going down the line. Your range is the terms, okay, or what you're getting from the sequence. Okay, so for this sequence, it would be 4, 8, 12, 16, and we would keep going up. So your range is like your y's. It's what you're getting out of the sequence. Now, when I look at sequence number 1 with what we just said, what would the domain be? Term 1, 2, 3, 4. So I have 4 terms, 1, 2, 3, and 4. The range is what the sequence is actually giving you. So my range, term 1 is 4. Term 2 is 8. Term 3 is 12. Term 4 is 16. Okay, so again, the domain is the term. The range is what you actually get out of the sequence, what the sequence is giving you. So what does that tell us for sequence 2? Domain is still going to be the same for this. We have term 1, term 2, term 3, term 4. And the sequence, what are we getting for the range? 5, 10, 15, 20. But the difference here is this dot, dot, dot. What does that mean? Just use your head. We've got commas, so we're breaking in between. There's no dot, dot, dot up here. There's a dot, dot, dot. So if there's a dot, 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 what does that mean about this sequence? It's going to keep going. Okay, so that's why I have a dot, dot, dot in my domain and in my range. Those are both going to keep going. So my domain is 1, 2, 3, 4, but I put a 5 here with a dot, 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 understanding that it's not stopping. And then again, my range, what I'm taking from my sequence, 5, 10, 15, 20, I continued it 25, dot, 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 again, because it never stops. Now, these two types of sequence have names. The first one is called a finite sequence. Why do you think? What does finite mean? Finite means it stops. Okay, so we have a last term. It stops at term 4. Okay, it does not go any further. It stops at term 4 when my range is 16. Sequence 2, though. If sequence 1 is finite, what's sequence 2 with these dots? Sequence 2 would be infinite. Okay, and why infinite? Because what does infinite mean? It keeps going and going and going and going. Okay, so those dot, dot, dots are infinite sequence where they keep going. They continue on. They never stop. Now, hopefully you recognize this is very similar to something else we've seen in the past. This sequence notation is very similar to y equals mx plus b. Very similar. Okay, and a lot of our sequence that we're going to talk about today are going to be similar to that. Now, one thing that you need to understand is this beginning part, this a sub n. This n is what we call our index, and it's always going to tell us where we're at in the sequence. Okay, so this is kind of, in a sense, going to tell us the term. Are we at term 1, term 2, term 3, term 4? Okay, so if we were at term 10, this would be a sub 10. And that would tell me where I'm at. I'm on the 10th term. Okay, so that n is called our index. Now, I already labeled it in here for you, and we're going to explain where these came from. Domain, remember we said that's our term. I'm on the first term, second term, third term, fourth term. That's your input. Okay, what are you putting in? That's your x's, your input, whatever you want to call it. Your range is your output or your y's. What are you getting? Remember, your range is your output. What are you getting? So when I input 1, 2 times 1 minus 3, well, 2 times 1 is 2, minus 3 is negative 1. Okay, so domain and range are the same concept as what you've learned in the past. Domain is your term. It's what you're putting in. Term 1, range is what you're getting out. When I plug it in, I get an answer of negative 1. So same thing for the second term. Second term, term 2. So when I put that in, 2 times 2 minus 3. Well, 2 times 2 is 4. 4 minus 3 is 1. Same thing here, term 3. So 2 times 3 minus 3. 2 times 3 is 6. 6 minus 3 is 3. Same thing, fourth term. I could keep going. 2 times 4 minus 3. 2 times 4 is 8. Minus 3 is 5. Okay, so domain, it's the term, where you're at. Range is what the sequence gives you, what the function gives you in return. That's your output. Now, write the first 6 terms of the sequence. Okay, so these are pretty basic. They give you the sequence. What are the first 6 terms? Okay, so the first one, here's my first 6 terms, 1 through 6. So if I plug in a 1 right here, all it is n squared, so it's 1 squared. Well, pretty easy. 1 squared is 1. How about 2? 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. Okay, so they give you the function. They give you the sequence. You tell them the terms. So same thing here. 1 cubed minus 1. Well, 1 cubed is 1. Minus 1 is 0. 2 cubed minus 1. 2 cubed is 8. 8 minus 1 is 7. 3 cubed minus 1. 3 cubed is 27. Minus 1 is 26. And we could keep going. 4 cubed minus 1. 5 cubed minus 1. 6 cubed minus 1. Now the second one, same concept, you just have 2 n's. So you take your function, you take your term, and you plug it in for both of them. So we have 1 squared over 2 times 1. Well, 1 squared is 1. 2 times 1 is 2. So we have 1/2. 2 squared over 2 times 2. 2 squared is 4. 2 times 2 is 4. 4 over 4 is 1. And like I said, you would just keep going. So that's basically a plug and chug. Take your terms, plug them in. Now we're going to go the other direction. Okay, this time they gave us the function, told us to find the first 6 terms. This time they're giving us terms and they want us to write a rule. Write a rule is like writing the equation. Okay, so we have a couple other things that they want us to do too. Write the nth term, or I'm sorry, write the next term. So what's going to come next? And then write the rule, write the equation. Okay, well, in order to do either one of those, we have to know the pattern. So what's our pattern for this first one? 2 to 5 to 8 to 11. From 2 to 5, we add 3. 5 to 8, we add 3. 8 to 11, we add 3. Okay, so my pattern is I add 3. Okay, like I said, today we're going to start off pretty basic. So let's think about our y equals mx plus b that we talked about. If I'm adding 3 to every single step, where is that? Is that my slope or is that my b? Every step I'm adding 3. That is my slope, 3x. Now, the second thing you need to make sure you do for your rule is where do you start? I need to start at 2. My first term is 2. Well, right now, if I just have y equals 3x, if I plugged in a 1 for my first term, I would get a 3. But when I plug in a 1, I need to get a 2. So how do I get 3 when I plug in a 1 for x to turn into a 2? I need to subtract 1. So my function is going to be 3x minus 1. I need to subtract 1 to make that 3 turn into 2 at term 1. Now my next term, well, it's pretty easy. You need to just keep adding 3, so 11 plus 3 is 14. So my next term is 14, and my rule is 3n minus 1. Okay, and I wrote 3x minus 1 over here. Same thing, doesn't matter. Okay, the next one, what's my pattern? 1 to 5 to 9 to 13. Each time we add 4. Okay, so let's start with my next term. If I add 4, what's my next term? My next term will be 17. Okay, now let's think about our function again, or our rule. I'm adding 4, so that's my slope, right? That's my slope. But my first term right here is 1. Well, if I plugged in a 1 right now, I would get a 4. So how do I take that and make my first term a 1? I need to subtract 3. So my next term was 17, and my rule is 4n minus 3. Okay, the next one. Ignore the negative signs for a second. Just look at the numbers. 5, 10, 15, 20. So I'm going up by 5 with alternating signs. Okay, so let's think of that. Going up by 5, that's my slope, so 5x. Okay, and then think about my first term. My first term is 5. Okay, so if I put a 1 in here, I get a 5. So I'm not adding anything because I'm already at what I want my first term to be. I want my first term to be a 5. Okay, so this is going to be the general basis of my rule. I'm going to add something to that here in a second, but this is the general rule, just 5x, okay, because I'm already at 5. I don't want to move. Now, if I added 5, what would be my next term? 22, 25, and is it going to be positive or negative? We're switching signs every single time, so 25 is going to be negative. But here, this is what's going to get me my alternating signs. We already said the 5n, or the 5x. That was my function. But this negative 1 to the n, how does that give me this positive, negative, positive, negative? N's the power. So if I have negative 1 to the first, my answer is going to be negative. And then if I have negative 1 squared, my answer is going to be what? What's negative 1 squared? Positive. And then the next one would be negative 1 cubed, which is again a negative, and then negative 1 to the fourth is now positive. So this negative 1 to the n is what's making my first term is negative, negative 5. Then my second term was a positive 10, because when you square it, it's a positive. Third term goes back to being a negative. Fourth term is a positive. So anytime you have those alternating signs, that's what this negative 1 to the n is. Now the next one. Okay, these fractions look different all the time, but this one is a rule on the top and a rule on the bottom. There's two different things going on. Up at the top, I'm going from 2 to 3 to 4 to 5, so I'm adding 1 each time. On the bottom, 3 to 5 to 7 to 9, I'm adding 2 each time. So when I'm looking at my rules, well, let's do the next term first. 2, 3, 4, 5, so on the top, what are we going to have next? A 6. On the bottom, 3, 5, 7, 9. So on the bottom, we're going to have an 11. Okay? Now, the rule, I'm adding 1 each time on the top. So what's that going to look like? My slope. Y equals mx. So what's my slope? 1x. On the bottom, I'm adding 2 each time. So that's going to be 2x. Okay, but again, where do we start? My first term on the top needs to be a 2. Well, if I put a 1 in here, it's going to be a 1. So what do I have to do here to get this to be a 2 at the first term? I need to add 1. On the bottom, 2x, because we're going up by 2 each time. And then again, if I put a 1 in here, this is 2 times 1. I'd be at 2. But I need my first term to be at 3. So this would be 2x plus 1 to get me to that 3. So my rule is n plus 1 over 2n plus 1. And my next term we said would be 6 over 11. Okay, so hopefully this is a basic understanding for you for sequence and series. And like I said, we're going to dive deeper into this in the next couple of days. Here's your homework, practice B, practice C. Hope you enjoyed the short notes today.